Okay, for number 41, we're given a polygon that's inscribed inside the circle. We're given information about angle AC and angle A and angle C. Well, what's true about the opposite angles? What's true about opposite angles is that they're supplementary. So then I can say that the measurement of A plus the measurement of C is equal to 180 degrees. So because of that, I can go ahead and create an algebraic equation so I can solve for x. So 7x plus 17, 3x plus 13 equals 180. So this is 10x plus 30 equals 180. Subtract 30 from both sides, we get 10x equals 150. And then divide by 10, we get x equals 15. And we are done. All right, so because this triangle is inscribed in a circle and one side of the triangle is the diameter, I know that this is a right triangle. So therefore the measurement of ABC is 90 degrees and we are done. Okay, number 38 and 39. So we're given a bunch of information about the lengths of the segments. So let's look at, we're given that OM is equal to ON. So since these two segments are equal, that means that the chord CD is congruent to the chord AB. You were given a theorem that said that if the chords were congruent, then they're equidistant from the center. The converse is true. So what does that mean? That means that I can take the expression for AB and the expression for CD, and I can set them equal to each other. So 5x minus 17 equals 2x plus 7. So you have a three-step equation, so subtract 2x from both sides. That gives you 3x minus 17 equals 7. Add 17. We get 3x equals 24, and then divide by 3. So x equals 8. So 38 is done. We know what x is. And AB is given by the expression 5 times x minus 17. Well, you can make a substitution to figure out what x or AB is. So that's going to be 40 minus 17 or 23. So 23 units is the length of AB. And we're done. Okay, 36 and 37. So this deals with two tangents to a circle. What's true about the two tangents? Well, the two tangents, and they meet up at the same external point, point P. What's true is the tangents are congruent. So then it makes sense to set their measures, which are represented by expressions. So 3x minus 10 is equal to x plus 6. So now you just have a two-step equation that you can solve. So let's actually 3 steps. Subtract x, add 10. So then we get 2x equals 16, divide by 2, and you get x equals 8. So then let's go back and let's figure out what they want us to do. They want us to find x, so x equals 8. And the measurement of AP is given by 3 times x minus 10. So then just make the substitution. And then 14 is your answer for the second part. Okay, 33 or 34 and 35. So this goes back to chapter 10, I believe. We have inscribed angles, or angles that are inscribed in a circle. So you have to pay attention to where the vertex is. If the vertex is in the center, then the angle measurement or the central angle is the same as the arc measure that it intercepts. So they give us that angle measurement of arc BC is 50 degrees. Well, I know that the measurement of angle O, or I could say the measurement of angle BOC, is also equal to 50 degrees. Okay, now I have to find the measurement of angle BAC. So to find the measurement of angle BAC, we can use this equation. So the angle equals the arc divided by 2. And that's because the vertex of the angle is on the circle. So it's going to be half of the arc measurement. So 50 divided by 2 gives us 25 degrees. So the measurement of angle BAC is 25 degrees. And I am done. Okay, number 33. Find the measurement of A to the nearest degree, which means the nearest whole number. So if you want to find the angle measurement, this is when you have to use your inverse functions. And I'm trying to find the measurement of angle A. So in relationship to angle A, 9 is the opposite, and 4 is my adjacent. So I'm going to say cosine of angle A equals tangent of angle A equals opposite over adjacent. So then you do tangent inverse of 9 divided by 4, and that'll equal the measurement angle A. So on your calculator, you do second tangent 9 divided by 4. Make sure the mode is in degree mode. So then we get 66 degrees. Okay, number 32 is similar to number 31. We have to use trig to solve the triangle. So in relationship to the angle that measures 73 degrees, what do I have? I have the opposite and I have the hypotenuse. So I can use the sine. So sine of 73 equals 15 over x. Now, when the variable is in the denominator, here's where students make mistakes. There's algebra I can show you to back this up, but if you have a situation exactly like this, the shortest way to solve it is just simply to switch x and sine of 73. Okay, now I can put that in my calculator. So 15 divided by sine 73 degrees, and I get about 15.7 units. Now, there's a different way to do this. Because this is a right triangle, I know the measurement of this angle is 90 degrees. I have the other angle, or a second angle, that's 73 degrees. What is the measurement of this angle? Well, if you do 90 minus 73, you should get 17. So now I can actually use 17. I can use the cosine of 17 degrees equals 15 over x. Now, I can use this equation and it will help me, but I still have the same dilemma. I have a variable in the denominator. So my best advice to you is, if you have the variable in the denominator, just switch the variable with the trig function. And my answer, 15.7, and I'm done. Okay, for number 30, or 31, find the value of x to the nearest 10th. So this requires you to use the trig that you have learned to solve the triangle. So which trig function in relationship to angle 38 that measures 38 degrees? I have two sides. What are they? One is the adjacent, the other is the hypotenuse. So what trig function involves the adjacent and the hypotenuse? Cosine, right. So cosine of 38 degrees is equal to x over 12. So now I have an algebraic equation. I can solve this equation for x by multiplying by 12 on both sides. So x equals 12 times cosine 38. Make sure your calculator is in degree mode, and the answer you should get is 9.5 degrees. Correction, it's the side length, so just 9.5 units. And we're done. Okay, number 28 through 29, this requires you to go back to, or 28 through 30, this requires you to go back to trig functions. Your teachers probably gave you a little acronym, mnemonic device actually called SOHCAHTOA. All right, so means sine is equal to opposite over hypotenuse. So if you look at angle A, which side is opposite angle A? The side length of 15. And what's the hypotenuse? Hypotenuse is always opposite the 90-degree angle. So that's going to be 17. So 15 over 17 is the answer for number 28, and I'm done. 29, you got to find the cosine. Cosine is always adjacent over hypotenuse. So what side length is adjacent to angle A? Well, that's 8. And what's the hypotenuse? That's 17. And I'm done. Tangent is going to be the opposite over the adjacent. So the opposite, and this time it's from, or the tangent of angle B. So what is the opposite side length? 8. And what is the adjacent? 15. Adjacent just means next to. So if you're unclear, one thing you can do is you can identify what the opposite side is, what the hypotenuse is, and then that third side has to be your adjacent. And I'm done with 28, 29, and 30. Okay, it's number 26 and 27. This is a more difficult case of the special right triangles. You're given the leg that's opposite the 60-degree angle, and it's in the form of a radical. So find the short leg first. To go from the side opposite the 30-degree angle, or opposite the 60-degree angle, to the side opposite the 30-degree angle, simply divide by radical 3. So x is equal to square root 27 divided by square root 3. That's the same thing as the square root of 27 over 3, which is square root 9 or 3 as my final answer. If I know that the short leg is 3, well, I can just double that to get the hypotenuse. So this is 3 times 2, or 6. And I am done. Okay, so for number 24 and 25, these are 30, 60, 90 special triangles, special right triangles. So this is the easiest case because you're given the side that's opposite the 30-degree angle. You should know that the hypotenuse is double that, and the side opposite the 60-degree angle is the short leg times radical 3. All right, so a reference diagram that you can use is this. the short leg is 1, then the hypotenuse is 2, and the leg opposite the 60-degree angle is the length of the short leg times radical 3. All right, so for this one, I'm done. This is 8, this is 4 radical 3, and we are done. Okay, so these problems, they're similar to the one before, but now I'm given the hypotenuse, and I need to go to the find the legs of the triangle. So recall, as I said in the previous problem, to find the legs given the hypotenuse, you just divide by radical 2. So because it's a 45-45 triangle, x and y are the same, so x equals y, which equals the hypotenuse divided by radical 2. This can be rewritten as 18 over 2, or the square root of 9, which equals what? Correct, 3. And we're done. Okay, so this is a section or problem about special triangles, namely 45, 45, 90, as well as 30, 60, 90 triangles. So this is the easiest case because you're given a leg of the triangle, and if it's a 45, 45, 90, what do you know? The triangle is an isosceles, and to find y, you just multiply by square root 2. Notice that if I wanted to go from the hypotenuse, to the leg, I would divide by square root 2. So keep that in mind for the next problem. All right, that's 5, and then this is 5 square root 2, and I am done. Okay, 19B is a different type of problem. On your final exam, when you take the final exam, you'll have a formula sheet, and you want to make sure that you pay attention to certain formulas. All right, so what formula you want to pay attention to? A couple of them. Well, first one is E sub I, and that's how you find the measurement of each interior angle. So it'll be n minus 2 times 180 divided by n. What about each exterior angle? You can find each exterior angle by saying 360 divided by n. All right, so let's see. Let's find each interior angle, and it's a 22/9. So I'll say 22 minus 2 times 180 divided by 22. So 22 minus 2, that gives me 20. 20 times 180, that gives me 3,600. So 3,600 divided by 22 will give me a decimal number, so it's approximately 163.6 degrees. All right, so that's the measurement of each interior angle. Let's find the sum of the exterior angles. Well, let's go in order. Let's find the sum of the interior angles. So then on your formula sheet, it's going to be S subscript I. So the sum of the interior angles is given by n minus 2 times 180. So that's going to be 22 minus 2 times 180. And that answer is 3,600. What's the sum of the exterior angles? Well, that's indicated by S subscript E. The sum of the exterior angles is always 360 degrees, no matter what shape you're dealing with. And the measurement of each exterior angle. So if it's 22 sides, you do 360 divided by 22, and that's how you'll get your answer, which is about 16.4 degrees. Okay, 19A. Classify a triangle with the sides 5, 6, and 12. First of all, is it possible to have a triangle that have these side lengths? We can determine that by taking the smallest two values, 5 plus 6, adding them together, and will they be greater than 7? Yes. So because the smaller two values are greater than the largest value, we know it's possible to make a triangle. So then now we're going to use these rules. This is the converse of the Pythagorean theorem. And if you have c squared being greater than the sum of the other two sides squared, then you have an obtuse triangle. If c squared is less than the other two sides, the sums of squares, then you're going to have an acute triangle. And what if you have c squared is equal to the sum of the squares? Well, that's going to be a right triangle. So now you just got to think about which side or which number will represent c. Well, c is going to always be the longest or the largest of the three values. So you take 7 and you square it, and you compare it to 5 squared plus 6 squared. So that's 49. This is 25 and 36. So I know that this will be less than the 25 plus 36. Therefore, I can classify this triangle as being an acute triangle. Number 7, we're told that BC is parallel to DE. You can take this one shape and imagine that it's really two triangles, where 4 and 9 are the lengths of two of the legs for the first triangle, and then 7, 4, 9, 12, and then 7 is the length of one leg of the larger triangle. So let's figure out what CE is. So let's call CEX. Well, because BC is parallel to DE, we have the following proportion. AB over AD is equal to AC over AE. The length of AB is given, it's 4. The length of AD isn't given, but we can figure it out by adding up the two lengths. So technically, it is given. AC is 9, and the measurement of AE is 9 plus x. So I will use this proportion to solve for x. Cross multiply, we get 36 plus 4x equals 63. Subtract 36 from both sides, and we get 4x equals 27. Divide by 4, and we get 27 over 4. You can also convert that to a decimal. Okay, 8, find the length of DE. Let's call this y. So I can set up a proportion 4 over 12. That's using the leg and the base of the smaller triangle equals 7 over y, the leg and the base of the larger triangle. Cross multiply, we get 4y equals 84. Divide by 4, and you get y equals 21. Okay, problem number 5. A street light cast a 50-foot shadow at the same time. Mr. Smith is a 6 foot. At the same time, Mr. Smith, who is 6 feet tall, cast an 8-foot shadow. So we're going to use proportion, and you want to use the same quantity over the same quantity. So, for example, you can have height over shadow. So what's the height of Mr. Smith? He is 6 feet tall. What is his shadow? His shadow is 8 feet. Well, what's the height of the street light? We don't know. But what's the length of the shadow? Well, that's on the ground. We can measure that. We determine that that's 50 feet. So then now we can cross multiply, and we get 8x equals 300. Divide both sides by 8, and we get 300 over 8. So you can put that in your calculator, and you can find the decimal equivalent. And now units will be in feet, and that's the height of the street light. Hello, this is Mr. Morton, and this is a first of many videos on second semester review packet for Geometry CP. Okay, for number one, you're given two triangles, or that two triangles are similar. You have to find the scale factor. To do that, you simply use the order of the triangles and identify corresponding sides. So we will say 5 over 2, or we can write it as a ratio, 5 to 2. For 2 and 3, we can use our scale factor. Let's label AC X and EF Y. So to find AC, I would say 5 over 2, and that's equal to X over 4. Cross multiply, we get 2X equals 20. And once you divide by 2, you get X equals 10. For number 3, you can use the scale factor again. And this time I'm going to say 12 over Y. Cross multiply, so we get 5Y equals 24. And that is the same as, once you divide by 5, you get Y equals 24 over 5, or 4.8 as a decimal. Okay, 4A is absolutely true. If shapes are similar, the corresponding angles are absolutely congruent. And for 4B, what is the ratio of the areas? Well, you can use the scale factor to find that. So the ratio of the areas is similar to the ratio of the sides. You just square the two. So we get 25 over 4, and this is our answer.